Hey everybody, today I'm going to show you a project that is the proverbial 80% done, which means that 80% of the work is still left to be accomplished. I'm trying to build up a Boolean algebra simplifier, and I talked a little bit about Boolean algebra in a previous video, but basically what I'm trying to do is I have a scheme to create Boolean expressions, and I want them to automatically simplify themselves. So a good example of what I want to accomplish, and I already have accomplished it, at least for these test cases, is negative absorption. And what that means is that if you combine x using the AND operator with not x or y, then essentially what happens is that that's the same as saying x and y. And it's a little difficult to reason about, but basically there's like some redundancy going on. That if you you know that not x can't work given the fact that x is part of the overall and expression, so it might as well not be there, and so then you end up getting x and y. And all these reductions for Boolean expressions are things that you learn about in a university logic class, and they're very completely well understood. But I wanted to try to implement them, and basically I so far have been able to implement all the standard reductions. Like De Morgan's law is kind of famous. It basically says that the negation of an and is like the or of two negations, and vice versa, that the negation of an or is just the same as an and of two negations over the same variables. And I am testing this with actual variables. The actual De Morgan's rule says that x and y can be arbitrary expressions, and that's kind of the bit of complexity that I haven't yet implemented yet. But the reason I say I'm 80% done is that these are all tests that work. And like, I don't know, I would consider this an impressive beginning to the project. And so far, I'm doing it essentially 412 lines of code. I borrow this very small library of my own that's like 45 lines of code to do some dispatching, and I'll probably talk about that a little bit later. But I'm basically under 500 lines of code, and I would say that I have a pretty strong proof of concept that I am understanding these rules of logic and implementing them in my simplifier. So I think what I'll do next is show you some of the code that I've written. And you can see the overall structure of the project fairly quickly. So I have the base expression class, and has a couple magic methods to allow like Pythonic creation of Boolean expressions. And then the kind of one of the most essential paradigms of my program is that when you combine two expressions together, sometimes the other expression is just a looser expression than your first one, and so if you're anding yourself with some other expression that just loosens it, then it's the simpler expression is just the original expression, because that other expression is completely redundant. And the rules for or look very similar, except it's sort of flipped. If I have an expression and I want to or it with the other expression, and the other expression is just going to restrict me, then I just return myself, because the other expression restricts me, is too restrictive. And if you pass in values that are satisfied by self, then the other expression wouldn't even be evaluated, and if it were evaluated, it would never provide more opportunity for truthiness. And likewise, if the other expression loosens me, then I should just use the other expression. Now, this restricts and loosens. It's not an either or proposition. There are some situations where the other expression could potentially overlap me because it might operate on different variables. We can't always use these simple rules. If these were the only two rules, then this would be an easy problem to solve. But let me give you kind of a high-level view of the object hierarchy here. You have a true value expression, which is literally just like encapsulating Boolean true. You have a false value expression. You have a signed variable, and that just means like, that could either mean like x or not x for a single variable. And then you have clauses, and this clause here is just like, this is using implementation inheritance, just sharing a little code between the two objects that we actually create, which you can either create an or clause, and an or clause would just be like x or y or z or not w. But it's just really just a list of variables that are all ORed together in a very simple way. And then you can have an and clause, and again, that's just like w and x and not y. And again, that's just a simple list of variables that are all just anded together. But then when you start getting more complicated, you can have a disjunction, and a disjunction is a series of and clauses that are ORed together, and a conjunction is a series of or clauses that are anded together. But that class hierarchy is sufficient to describe any Boolean expression. Or I should put it a little more precisely. It is a well-known fact that any Boolean expression built out of and, or, and not can eventually be simplified either into a conjunction or a disjunction, or actually both. Usually, it's some Boolean expressions can be expressed more concisely in a conjunction, others in a disjunction. But the way that I implement this right now is getting kind of yucky, and that's why I sort of preface this by saying that this is what it looks like when a project's 80% done, but the last 20% takes 80% of the time. But I basically have all these different rules for combining expressions. Some of them are actually quite simple. Like if I know that my first expression is a true value and the other expression is any arbitrary expression, and I OR those together, well, then I'm always going to get true. And likewise, if I OR a false value with any other expression, then it'll be that expression, because ORing something with false doesn't loosen the expression at all, because false is always false. And I think this is expressing the identity reduction, and this is expressing the annihilator reduction. But anyway, I'm having to combine these things together. Basically, like every pairwise combination of these data types, I'm having to write a little bit of code for it. And you can see that like these are all basically one-liners. There is a little helper function up here that's a little bit ugly. Well, there are actually two helper functions that are slightly ugly, but they're not horrible. And there's one other, this is probably the grossest function, but really all this eliminate terms doing, all that it does is that it basically does a doubly nested loop over a bunch of predicates, and it keeps checking the predicates pairwise to see if one is just either restricting the other in the context of uh, building ands, or if it loosens the other in the context of building ors. I think I got that right. See, yeah, when you have an and expression, you want to eliminate any loosening terms. I might have said that vice versa, but that's the basic idea. So everything so far has been pretty nice. But and if you look at the test, you'll be like, wow, this looks like it's almost done. I mean, I not only have proven that at least for all the for the simple case of two or three variables that I am obeying that I am implementing the basic reductions and doing them properly. But like further down, you can see that I test some like more complicated reductions just to kind of make sure that everything's playing nice together. But I know that I haven't implemented everything just from reasoning about the program, and then so the where I am now in the process is I've created a stress test, and what I do with this stress test is I fill up a bucket with just these four expressions, and they're literally like true, false, the variable x, the variable y, and I go into this big loop, and every time through the loop, I'm trying to build up a bunch of other expressions. And like this is where I try to not the expression and then I double negate it. And then I do kind of a pairwise loop where I try to combine all the A's and the B's, or for every A, I combine it with every possible B. For every A, I also OR it with every possible B. And then this handle function like basically runs a check just to make sure that the expression evaluated. And this is a good technique. Like I'm basically trying to hunt down situations where my code can fail. And sure enough, that's where I am. So if I run the stress test in my terminal, the output's kind of ugly. All this output up here indicates some level of success. These are all this like little bucket here. These are all expressions that I have successfully created. But you can see here, this is kind of hard to read, but I get down to this trace back and I can't and together these two expressions. This first one is an and clause, and then the second one is a disjunction. And I don't have a rule that says how to combine an and clause and a disjunction. Now I know I can write that rule, and if I go back to GitHub, I know that the rule is gonna look roughly like one of these things here. Like all of this code is very similar, and that's kind of a code smell in and of itself. And so that's where I am right now. So my strategy for the next, at least few hours is I'm just going to keep running that stress test, and I'm going to keep implementing new rules that I haven't yet implemented, because there are only like 5 different classes and pairwise combinations. There are only about 25. So and I already have a good momentum on knowing how to create these things. So I'm going to probably just keep plowing away and see if I can get this stress test passing. But I'm also at the stage where I'm like starting to think about, well, is there just a better way to do this? And I'm about to end it. I just want to point out one final thing. Like this really is a well understood problem, and it's been solved before. And I know I'm not like ridiculously far off, because the most popular Python implementation of what I'm trying to do takes 1652 lines. And I've read this code. Like the first 500 lines of it are mostly doing parsing, which is out of the scope of what I'm trying to do. So I know that in order to implement this, if I can do it in about 1,000 lines, then I'm doing something like relatively reasonable. I'm not doing something completely gross. And I also know that like I'm not overlooking some like incredible way to do this in 100 lines of code. Anyway, that's where I am, and I will do another video when I've made further progress. And I don't know what I'm going to discover in the next day or so, but that's part of the process. Thanks for listening.